Anyway, thank you guys for joining us today. I'm Anders Graham, Senior Manager of SSD Product Marketing at Samsung Semiconductor here in the US. I also have Anson Sui with me down here to my left. He's on the DRAM marketing side. So we have a quick presentation for you guys, just talking about future memory and storage technologies that we have that are fueling innovation in the cloud, right? And real quick, I just want to talk about the data problem. If you guys attended the Microsoft keynote, were you guys in the Microsoft keynote earlier? Most people. So he had a pretty good stat on this. He went even farther out than I did, right? He went to 2025, I think it was 175 zettabytes, right? So just a crazy amount of data that's being generated. I think he said it was a stack of DVDs will go around the world 200 times, something crazy like that. But the other key thing to think about here is that with data scaling, compute is not scaling as fast anymore, right? So the compute resources that we're working with are really not the same as they used to be. And to make things worse, a lot of this data is being created at the edge. So these are all the problems that we're having with data now, right, that we maybe didn't face before. And another way to think about it is a lot of this data, right, how do we figure out what data is important, right? I found this kind of amusing. I don't know, hopefully some other people have a weird sense of humor like I do. But how do we find the data in the haystack, right? And so today we're going to talk about some of the things that Samsung is doing to help you guys figure this out moving forward, right? How do we increase capacity effectively, have higher speed, lower power, better time to insight? So the three pillars that we're presenting today at OCP, if you go over to our stage over here, really are unrivaled technology, where we're looking at our DRAM, our NAND technologies, the all NVMe data center. So Samsung has been a pioneer in NAND and an SSD, and specifically an NVMe SSD, right? And bringing those to market and having a full portfolio to help you guys out in that area. And then the last piece, which I'll touch on briefly and introduce some folks that are having a follow-up session later today, is intelligent storage, right? Key value SSD, smart SSD, some of these concepts that we're going to be showing you guys later today. So with that, let me bring up Anson here to talk about our DRAM technology.
Thanks, Anders. What I wanted to do was just give you a little bit of an overview of DRAM technologies and where we're at today. So Samsung, we've been the market leader in DRAM for more than 2 decades. We support all different kinds of DRAM, so that includes your mobile DRAM, PC DRAM, server DRAM, and specialty DRAM like graphics memory and also HBM. So today where we're at is our 10 nanometer class DRAM products. And just last year, I think it was in the middle of last year, we introduced the industry's first 16 gigabit based DIMM for server applications. So what I wanted to do is just hold that thought. I wanted to switch gears a little bit, and I wanted to just take a look at something a little bit more fun. So if you want to just see the impacts of power consumption and what data centers have done as far as power consumption or the impact that they've had on the world, I wanted to look at sort of electricity usage around the world, right? Just to get a sort of a baseline. So if we take a small country like Singapore, for example, they typically run about 50 terawatts of electricity per year, right? And then if we take Sweden, they're around 130 terawatts per year. And then you guys kind of get the picture here, right? So then we have Mexico, we have the UK, and also France, right? So what's amazing is that when we look at the power consumption or electricity that's used by all the data centers in the world, it's actually more than some of these countries, right? And some of these countries combined. So I thought that was pretty cool. The other thing is now, so where is power being used within a data center, right? So it turns out actually 50% of the power is used by servers, right? So I think that's one of the big reasons we're all here at OCP is to figure out how do we make data centers more efficient, right? So now going back to those 16 gigabit products that I talked about earlier. So if we take, for example, the most typical DIMM that's out there in server applications, it's a 32 gigabyte register DIMM, right? Today, most, if not all, of these DIMMs are based off of 8 gigabit components, right? But now with these 16 gigabit base components, I mean, we can quickly see there's a 15% power savings there just on the DIMM alone, right? So now, what does this mean for the server and the impact of power consumption and saving the servers from these 16 gigabit components? So if you take a typical server that runs about 250 watts, right? And we look at a typical configuration where we're populating 1 DIMM per channel. So now we have 12 DIMMs for a 2-socket server. The DRAM portion is actually almost 25% of the power budget, which is pretty significant, right? So just by moving from an 8 gigabit to a 16 gigabit based solution, we can shave about 4% off the total power consumption of the server itself, right? So 4% doesn't seem that big, right? But again, remember, servers contribute about 50% of the power consumption within a data center, right? So, and the other thing too is if we look at it from a dollars point of view, just from recurring electricity costs, operating costs, you can save more than $500,000 per year by just moving from an 8 gigabit base DIMM to a 16 gigabit base DIMM. So for a more memory intensive type of workload, like for example, SAP HANA application, I mean, we have the same benefits too for our 64 gigabit base modules as well. So now instead of populating only half of the DIMMs for in a more memory intensive application, let's say we populate all the DIMMs now. So now 24 DIMMs are being used for a 2-socket server, right? So just by moving towards a 64 gigabyte module with 16 gigabit components, we have the same kind of power savings, right? In this case, roughly about 16%. At the same time, now that we're moving to a 64 gigabyte solution, you're actually freeing up, those half of the DIMM slots, right? So now you're going from a fully populated DIMM configuration to a half populated DIMM configuration. So not only do you save on power, but now you have more flexibility. Like if you ever need to do future memory upgrades or you need to plan for that, now you have the option, right? So that's just another one of the benefits here. So I talked about sort of those mid to higher density type of workloads, but I just want to remind you guys too, I mean, we support all types of workloads. So if you guys have a lighter workload, for example, like a web server, we have capacities to support that at the low end. Again, for the mid-range capacities, for cloud computing, virtualization, those applications, we have those products as well. And then for the more demanding applications, which need more memory, we actually have solutions with our 256 gigabyte DIMMs available. So what that means now is that you can actually populate a 2-socket server and get up to 8 terabytes of memory, which is pretty crazy, right? So, with AI training and stuff being proliferating more and more, and then we have in-memory computing, and also as CPU cores continue to increase, I think from a memory perspective, we're well positioned to support those needs. So if you guys have any questions on the DRAM side, feel free to stop by the booth. We can definitely go into more depth with you. And I'm going to pass it back to Anders, and he can let you know what's going on the storage side.
All right, great. Thank you, Anson. So I got about 6 minutes. So I'm going to power through some stuff here on storage for you guys. But switching gears over to the all NVMe data center, I want to talk to you a little bit about our NVMe portfolio. Real briefly, though, I want to touch on just 3D NAND. And I usually don't put these types of slides up here at these types of shows. But the reason I wanted to bring this up is that just for your awareness, a ton of 3D NAND has now come online, right, last year. And SSD pricing is much cheaper than it was even a year ago. So the reason I want to share that is that if you're using disk versus, obviously everyone's using disk. We're going to need high capacity disk for some time, right? But now is a good time to reevaluate how you're using flash versus disk, particularly performance type disk, things like that, because the pricing levels are much, much different than they were before. So definitely take a look at that. And the other thing to look at is whether or not you're using NVMe SSDs, right? So NVMe SSDs have now been out-shipping SATA SSDs for a couple of quarters, and that's really been driven by adoption in cloud data centers. That's really where we've seen a ton of adoption. So Samsung has been a leader in this area. We've taken products to market first, and we have a wide portfolio and kind of cover every area that you need. So this kind of planetary visual here for you depicts our NVMe SSDs, but it's kind of a fun chart. You have latency on one side and performance on the other, right? Lower latency is better, higher performance is better. Even though this product, the PM983, is up in this corner, don't let that fool you. It's a very low latency, high performance product, and this is actually the main runner that we have in the public cloud data centers is this data center class product that has a low power envelope, much better performance than SATA, and really good dollar per gigabyte. So this product comes in a U.2, an M.2 form factor, which has been very popular in a lot of open compute type architectures, and then also our NF1 form factor, which is depicted here. That's our new form factor that looks a lot like an M.2. It's a little bit bigger, right? But you can fit 36 of these in a one-use server. So we have 2 servers in our booth, 2 AIC servers showcasing 36 of these SSDs in a one-use server. So please come and check that out as well. And then on the enterprise side, right, we have high performance drives. These are going to be Gen 4 ready type products. We're getting ready for Gen 4. This is where you really get your best dollar per IOPS. And we also have a Z-NAND type product that is a low latency NAND that's been re-architected for the best performance and the lowest latency. So that's something that's going to fit into this persistent memory storage tier, if you will, as things start to move forward. And the last thing I'll say is these 2 products here, right, are dual port capable products that will see a lot of adoption in enterprise architectures in addition to data center class. So that's on the NVMe side. I really encourage you guys to look into NVMe. I mean, I'm sure you already all are already, which is why you're here. But everything is really moving to NVMe rather quickly. The last thing I'll talk about is intelligent storage. I'll just touch on this fairly briefly. We're going to have another session that goes into more detail in this area. But this is how we deal with the insane amount of data that's being generated, right? We have to look at different ways of designing the SSDs. And all of these designs are going to be based on the NVMe protocol, right? Not SATA, not SAS. So one of the things that we've introduced previously is something called the key value SSD, right? And this takes a look at the block interface and how can we replace that with a key value interface and reduce some of that software stack and really enable linearly scalability of performance versus number of SSDs per system. So this is something that we're working on. We'll have some product planning folks in our booth if you want to chat with them about this concept. They'd be more than happy to entertain you for as long as you can be entertained. The last concept I want to talk about is our smart SSD. So this is something that we announced at our tech day last fall, where we're actually looking at taking accelerators and putting them on the drive itself, right? So we're already seeing accelerators and SSDs working hand in hand at the system level, but once again, you're going to run into compute bottlenecks, which is the same issue that we're seeing with the interface itself, which is why we're looking at key value. You're going to run into compute bottlenecks in other areas as well, right? Moving the data up into the system, down to the accelerator, back and forth. We really think that for use cases like data lakes, fraud detection, AI, ML, and many other use cases out there, we can look at actually bringing intelligence to the SSD, and that could be a real game changer as we generate unbelievable amounts of data at the edge and try to figure out how to process that data, right? How to find the data in the haystack. Luckily, these 2 gentlemen are much more intelligent than I am, and they're going to be talking about our smart SSDs a little bit later today. So if you guys are interested in this concept, I really encourage you to come to our session at 425. And Michael and Pankaj are really going to get more into our NVMe portfolio. They're going to do a deep dive on the smart SSD concept and talk to you about what that really could mean for your applications. So please come and check out that session, and also come check out our booth too. We have a smart SSD demo in the booth that we're showcasing along with our NF1 based servers and high density DIMM solution. So I'll just leave you guys with these three key takeaways. You know, as Anson mentioned, definitely look at higher density DIMMs for better TCO. Definitely have to look at NVMe-based SSDs at this point. That's what everything in the cloud has been shifting to, and we've been a big part of a lot of those systems that are using open compute architectures with NVMe SSDs. And then lastly, really in the future, we need to start thinking about intelligent storage concepts to start breaking through some of these compute barriers that we're going to be facing as data continues to scale. So I think that's all I have, and I left 2:01, no time on the clock. So I guess no time for questions, but please stop by our booth. We'll be over there if you guys have any questions. Please feel free to stop by. Thank you very much.